Welcome and good afternoon. My name is Bethany Maddox and I'm a member of the customer care team here at Vitech Corporation. I'm very pleased to be your host for this webinar. Before we get started, I'd like to take a moment to review a few technical details. First, questions. Please feel free to submit your questions at any time via the Q&A function in the GoToWebinar window. We will be monitoring these throughout today's event. We plan to respond to questions at the end of the webinar, so please keep them coming. We probably will not have time to respond to all questions, but we need to know what's on your mind, and your questions will help guide our planning for upcoming webinars. And finally, recording. The webinar is being recorded today. If you have any technical difficulties during the presentation, an online archive with this presentation will be available within 24 hours of the live version. Okay, I believe that takes care of all our housekeeping matters, so let's get started. I'd like to take a moment to introduce Dr. David Harvey, our speaker for today's presentation. Dr. David Harvey is a systems engineer with a specific interest in model-based systems engineering. He holds a bachelor degree and a doctorate, both in the field of mechatronics. He currently leads the MBSE program at Aerospace Concepts. This team is developing an MBSE approach and tailored tool to assist in complex system definition in conjunction with Australian defence partners. As well as this development, he's also involved in applying the tool and approach to capability definition in major Australian defence projects. Please join me in welcoming our speaker today, Dr. David Harvey.
Thank you for the introduction. Firstly, I wrote this webinar with co-authors, so I'd like to thank Michael Waite, Paul Logan and Tommy Liddy, some of whom are probably online today. So today I'm going to talk about systems engineering, documents and models. Documents are pretty much a universally accepted method for conveying information when defining complex systems. They're good for all stakeholders in that everybody is happy to view information in this way, but they also have some deficiencies, lack of dynamic traceability, linking, consistency, some of these things. These problems, among other things, the sort of general environment, has led to a rise of MBSE tools to support system engineers and a corresponding debate about document-based system engineering compared to model-based systems engineering. Further to this debate, which is becoming somewhat redundant given the groundswell of support for MBSE over the last decade, we propose that the centricity or the focus of the approach is important. So focusing on the model development, not only on just filling in the required documents. So that is that we should not simply model a document, but instead should strive to document the model, and that hence the title of this webinar. So I'm just going to go through a brief scope of the webinar today. I'm going to have a fairly quick introduction. It's going to talk about a definition of systems engineering that I'll refer to later on, as well as a very, very quick history of system engineering, talking about its move towards model-based system engineering. I'm a systems engineer myself, so I like to think of things in terms of problem, context, and system solution. So in this case, I'm going to talk a bit about the context, which is the evolution of model-based systems engineering tools, and then talk a bit about the solution system, the evolved model-based system engineering support tools to actually support this evolution, and then move on to the main theme of the webinar, which is the importance of the intent and focus of approach. So it's the centricity as compared to the basis, and I'll spend quite some time talking about that later on. To illustrate this theme, I'll then take a look at an example model and document in a model-centric, model-based approach before talking about some of the benefits that you can gain from using this approach. And then I will finish with a conclusion and a quick take-home message, and as Bethany mentioned, there'll be time for questions at the end. So just very briefly, what is system engineering? So the definition we have here, system engineering involves taking a structured approach to definition, design, and implementation of systems that address defined user problems. So it's basically a holistic approach to system design across how the system is going to be used, the context of the system and subsystems, and the life cycle of the system. The history of system engineering in a formal sense dates back to at least the 1930s, as identified in the NCOSI handbook there, where it was applied to the problem of air defense. But informally, taking a holistic approach to system design can be traced much further back. However, with a rise in complexity, interconnectivity, and particularly a reduction in development time of projects and systems, is leading to an increased take-up of system engineering as we move forward. Good system engineering is inherently model-based. So this holistic approach normally involves some form of overarching model to work out how things are related. That's not to say that it needs to be done in a model-based tool. Good system engineering can be done in a model-based way in a systems engineer's brain. Particularly before the existence of system engineering tool support, this was the only way things could be done, and appropriate methods could be applied with paper support. But we've identified two major factors that have led to a need for greater tool support to help system engineers do their jobs. The first one is increasing complexity of projects as compared to the relatively static understanding capacity of humans. So we've illustrated that with a couple of references there. So the first one, Metcalfe's law, talks about the number of possible relations between nodes in a mesh. This number actually rapidly increases with additional nodes. I think the relationship's something like n squared over 2. It's close up there. So as you add extra elements in your system that you have to consider and how they interact, you're adding a lot more relationships that you have to consider. So the complexity increases very quickly as the range of things that are interacting increase. The other one we've got there is Miller's magical number from his seminal 1955 paper, where Miller was investigating human cognition limits and proposed that 7 plus minus 2 was a number that reflected the pieces of information that a human could consider at one time. Obviously, these are not exact numbers. They're more like worst case scenarios, I guess, but they're certainly indicative of the issue with increasing system complexity and the problems that humans have dealing with it without some form of external support. So one way of dealing with this conundrum is outsourcing. So that outsourcing of recording of the system's knowledge while retaining understanding of how you can actually find the information and how it is structured. That's analogous to a sort of wider move of outsourcing in our society. For example, the Google effect, humans having to remember less, know less, but being able to access much more information. That's the reference there. The second factor that we identified was the increasing use of teams of systems engineers. So in this case, you've got multiple people, often with different backgrounds, different experience, different specialities, certainly different contexts, and they all need to have some form of shared understanding of the system and its context, its environment. It's good to have that shared representation or understanding that everybody can access in a controlled way and contribute to in a very much controlled way. This helps keep everybody on the same page. So these two factors have led to the rise of tool support for system engineering. So in answer to this need, these tools have evolved over time. So at the top left, you can see, starting there with the human brain. As I said before, you can to some degree, and for some systems, do good system engineering with the model in the human brain. Moving on to pen and paper, so be able to record and share some of those that model or that understanding, those representations. Moving on to word processors, we've got Word there, which have a degree of linking, provide the model in electronic storage, or provide the documents electronic storage. Onto the early computer-based system engineering tools. Some examples of that include RDD, based on an automation of SysRem in the 1980s and 90s, or the Lockheed Systems Engineering Environment, which was used in the Dawn project in Australia in the previous century, through to today's full MBSE tools, which have underlying relational databases, and that's the outsourcing knowledge I was talking about. We've got the example of Core there, there's Genesis, and various others, Artisan Studio, Rhapsody, etc. There's a range of these. These tools can go a long way towards supporting excellent systems engineering work, but the point we're making is that these tools can be used to support system engineering that's either focused on the document required or focused on the system model. That brings us to the theme of this webinar. the centricity and how it relates to the traditional model-based versus document-based access that you'd be used to hearing about. So on the graph there, we have centricity on the y-axis, so that's going from the bottom document-centric to the top model-centric, and we have the traditional basis on the x-axis, going from document-based on the left to model-based on the right. These we would actually consider to be continuums rather than sort of discrete document versus model. So it's a continuum from document-centric to model-centric, but we represented it as a 2x2 matrix today, sort of for explanatory purposes. You can see that there are pictures in each of the quadrants which represent the 4 extremes that I'm going to talk about today. So the first quadrant, the bottom left there, you can see the red circle, represents document-centric, document-based systems engineering. Certainly at that extreme level there, it is an extreme case. We have all of the definition effort going into the documents. There's no overarching model of the system. This is a very unsystems engineering way of doing systems engineering. It's a fairly naive view, and given the definitions we gave earlier on, it's arguably not really systems engineering because you're not considering it holistically. It is possible to come out of this way with document artifacts that may get you recognized as having done a systems engineering job and get you through committees, get it approved, for example, but there's no way of knowing if these documents actually hold together as a cohesive whole. In fact, it's rather fairly unlikely and would be fairly lucky to produce consistent and useful work using this method. So moving on to the top left quadrant there with the model-centric document-based system engineering approach. So in this case we have the holistic model of the system in the systems engineer's brain, so they've thought about how everything interacts. And then the documents are populated from this model, i.e. the engineer writes things in documents. The only actual explicit links between these things are either maintained in the systems engineer's brain or they have to be recorded in a sort of static document. This was the only sensible approach to take before the advent of system engineering tool support. It does have some benefits in terms of overheads compared to using some of today's system engineering tools, but it has significant downsides in terms of dealing with complexity, increasing team size to more than one person, and reducing and avoiding errors. So now moving down to the lower right quadrant, talking about document-centric model-based. So in this case, the paragraphs, diagrams, sections of the required documents are modeled directly in the MBSE tool. And you're modeling only the documents required, not creating the documents for a model of the system. It's in our opinion, quite a misuse of the power of model-based system engineering tools. It's possible to use tools in this way, but it's like using it as a very expensive word processor or drawing program. You can have all the diagrams or pieces of section text you like, but if they don't have the single source of truth model of the system behind them, it's not model-centric. That's our point here. It's document-centric, and you're missing out on a lot of the benefits that you get from taking a model-centric approach, and you're still incurring some of the costs that come along with using a model-based tool. Finally, moving to the upper right quadrant, we have their model-centric, model-based approach. So in this case, you have an integration of a model about a system, so the engineering aspects of the system as well as the direct technical aspects of the system. So this is a sort of single holistic model that covers those things with the system context, so talking about the environment with which the system has to interact, other systems which it has to interact with, the way the user wants to use the system, and this is all over the life cycle of the system. So that's kind of taking that holistic approach I was talking about before. And then, so all the effort goes into defining that model, and then querying and traversal of the model is used to create the document artifacts at any time in the definition process. This approach uses MBSE tools to their fullest potential. It opens up a number of benefits, which I'll talk about later, and basically is the way that we try to work, and we would advise others to try and work that way too. So having talked through the relationships between model versus document-based and model versus document-centric approaches, and the 4 quadrant examples that I've mentioned, we're going to examine the document-centric and model-centric systems engineering processes in a bit more detail. So starting off there with the document-centric systems engineering process. So you can see in the diagram there, which is redrawn from Estefan's 2008 survey of MBSE methodologies. Starting in the top left, we have work on the requirements, the business rules of the user side, use cases, ConOps, moving down to system requirements and system architecture, subsystem architecture, moving on to requirements and functionality for the subsystems, implementation, testing. As you can see, this is presented in somewhat of a waterfall way, though we do have the circles there of arrows in the background indicating iteration. And in this diagram, all of those particular processes are supported by a set of documents. So the engineer's focus is on the production of the documents, not the definition of the problem and appropriate system solution. There's no reference to an overarching central model. Often the documents are the only things passed between those processes, so you have to, every time you start a new one, have to sort of decompose the documents, work out what people are talking about, create your own sort of start to the new process. There's no sort of reduced passing of information between the processes, and there's a lack of enforced consistency. So in a set of documents, it's very easy to have something represented a number of times, and if you change one of those things, it doesn't necessarily change other things. And this is also particularly true over time. That is not to say that documents are not useful. In fact, we wrote a recent paper talking about how useful they are in system engineering and how they're likely to continue to be useful over time. Documents are information in the form that stakeholders are used to dealing with, particularly useful for communication with people who are outside the direct system engineering team, who don't want to see a system engineering modeling language. They want to see information in a form that they're used to, they can understand. So documents can be used to help both gather and spread information about the system model, and they're often still used for review, approval, and contracting purposes. So we're not quite at the time where we can get sign-off on a model. Basically, you get sign-off on the documents that are related to the model, even if you're using the model-centric approach. But they should not be used as artifacts of the main development effort. That they should just be coming off the system development as artifacts themselves. So moving on to model-centric systems engineering. So again, using an adaptation of the Estefan diagram. So that has the addition of a model repository, you can see, but again, it starts from the top left with the requirements, business rules, ConOps, so all the user problem side. Moving on to the system requirements, system architecture, subsystem architecture, further onto the subsystem requirements functionality, and then implementation and testing. You can see that these all refer to the common model repository in the center there. There's also documents produced from that repository, but they are produced from a report generator as artifacts from the model rather than from the processes themselves. So in this case, we have the model development as the system engineer's major focus as they go through those processes. This is that model of and about the system contained within a model of the context and over the life cycle of the system. So it's that holistic model I was talking about earlier. The key artifact then becomes the model, but the documents can be used and still should be used, in our opinion, to capture information and particularly as fit-for-purpose outputs from the model for review and approval. You can basically choose any section of any view and combine them together to produce whatever document is appropriate. So that's one of the great benefits of using this approach. So in order to sort of underline some of the benefits I've been talking about and discuss further this model-centric, model-based approach. I've got an example here. We have a simplified model structure in the center there as it relates to the operational concept document. It's an Australian defence document to help sort of define how the user wants to use a system, and then there's sort of the higher level system solution. And there's the reference there if you want to go and look at exactly what it's all about. So in this particular example, we have in the center the simplified model. So we have, in this case, very, very simplified subsection of a model with a performer performing an activity. That activity results in a need. That need is the basis of a function. That function is allocated to a component. So that's the central model there. And then on the far left and on the far right, we have the document sections. So we've just taken sort of a selection of those sections there. So section 3, which talks about the sort of operational analysis, basically. We've got a mission overview, end user classes, and consolidated operational needs. This detailed operational analysis is found in Annex A, which you can see on the far right there, and that's just underneath Section 5, which talks about the initial system solution, I guess you could call it. So, we've got the material system description, architecture, and functionality and performance. So, as you can see, it's not just the central model and the document that we have there. We also have arrows from the model to the document sections showing how the information in the model is linked to the sections of the document. So that's how the document is produced from the model through query and traversal of the model. So as you can see, we have some instances here where the information from the model is represented in multiple places in the document for perfectly good reasons. So for example, section 3, we have operation activities, the activities there going to section 3.1, mission overview, so at a higher level. But they also go, there's an arrow from the activity down to Annex A on the bottom right, because that's where the detailed analysis of operation activity model is done. So it's represented in 2 different places. So were you to be using a purely document approach, you would need to, if you were to change anything in the operation activities, you need to change it in those 2 places. Whereas with this model in the center, it's a single source of truth. You make changes, then it's represented in both those places. Another example of that is the components there shown in the material system description as well as the architecture. So again, you got the same thing, or even if it's the same thing at different levels in 2 different places. So this consistency is sort of enforced through use of the single source of truth. Also, the act of modeling itself in a relational database introduces some degree of logical consistency. So in this example, we couldn't have a rogue function that doesn't appear, that doesn't relate to a need. It would not appear in a document that we produce from this model. However, if you were to just use the document-based approach, it's a lot easier to sort of fudge things, add in things that don't have any particular reason for being there. So this is one of the benefits of taking that sort of model-centric approach. This leads us on to the benefits of taking this approach. The focus on the information of and about the system leads to a number of benefits that I've been alluding to previously. They include traceability, so links are established and maintained as part of the approach. That's how you do the modeling. So you can identify this traceability and have it output in whatever documents in whatever way you want, but it's more than that. It's more of a total traceability. So if you're curious as to, for example, where a requirement came from, you can go into the model and look at the requirement, trace it back to a function, a user need, operational activity, overall mission. So you can look at exactly how things are interrelated to a greater degree than in just one sort of static representation in a document. It's particularly handy when examining the impact of changes to a specification, for example. So you can look at what else that change would impact upon by looking at what it's linked to. Another benefit is in consistency, and that's that single source of truth that I've been talking about previously. Information in multiple places across multiple documents, it's very difficult to keep track of, particularly over time. But if you can change something once in the model and then the document or a set of documents are produced using that model, that consistency is enforced. This is a great benefit to doing good system engineering. There's also adaptability benefit, so any number of views or documents can be produced as snapshots or of slices of the model. So for example, in that last model example I showed you, we were looking at producing a defense document and an OCD. If you wished to produce a commercial document, for example, some form of operational concept or a system and subsystem specification, test specification, you can produce that from the same model by just defining where the different bits of information need to appear in that particular document, and then running the sort of query and traversal generation. That's a very powerful tool to be able to do that and be able to produce any fit-for-purpose views for subsets of stakeholders that are still related to the sort of holistic model. There's also benefits in robustness and information sharing. So the understanding of the system is made explicitly clear, and it's a lot more shareable in that type of when it is modeled. And it also helps with domain specialist views being possible, so that's taking into account one domain but without neglecting the interconnected nature of other domains, because we have this holistic model that has the things all connected, so you can look at one bit of it but also still be aware of what that bit is connected to. Okay, so in conclusion, we would put forward that all good system engineering is and always was model-based in some way. Now, that model previously existed in the system engineer's head, but has today progressed to model-based system engineering tools. This is not to say that documents are not important, and we've put forward that documents are still an important part of model-based system engineering for communication, and they're likely to remain that way, because as systems engineers, it is our job to communicate these concepts to people who aren't system engineers. That's almost the definition of what we do, is as part of, as well as looking inwards to the engineering, looking outwards to the rest of the community. With the rise in complexity of projects and project teams, MBSE tool support is required, and that tool support has evolved to support that need. So as well as the basis, so whether you're using a model-based tool or you're continuing to work in a document-based way, we put forward that the centricity of approach, whether you take a focus on the model-centric, or focus on just the documents you need to get past a certain committee, document-centric, we're proposing that's very important. And the fact that taking a model-centric, model-based approach uses current tool support to its fullest, it enables a number of benefits that I've talked about previously: the traceability, consistency, adaptability, robustness, and information sharing. And this is the way we should be using our current tools to get the most out of them. So to just distill that down even further, it's not enough to talk about model-based versus document-based system engineering. The focus, or centricity, is very important too. And engineering a system using a model-centric, model-based approach uses modern tools to their full extent and brings a number of benefits. This is how we should be doing our work. So I'll just leave up the references for a few seconds there in case you guys want to check out any of the papers I've been talking about in the webinar. And then it's time for questions.
Thank you, Dr. Harvey. We've already received a few questions. I encourage all of our attendees to join the discussion and submit your questions at any time. You can use the Q&A function in the GoToWebinar window. Our first question here is from Ron, and Ron asks, why is what you're describing different to using a model to ensure document content consistency?
It's a matter of the focus, the centricity. So if you were to just use a model to ensure document consistency, if you just model the document yourself, you're using the document template as your sort of model specification and the design of your model. And when you do your work this way, the generated document may be deemed complete, but the system model is not, because you haven't gone towards understanding the system. You've just filled in the document, but in an expensive system engineering tool. In a model-centric approach, the model is worked on until the required understanding of the system is achieved, and then you just report on that understanding via various documents. The documents can then be structured for the audience in a fit-for-purpose manner. So if you need to address a certain document template, then you can structure it in that way. But the documents are just an output of the model. They're not a driving consideration. And we put forward that that's a much better way to do this system design and definition.
Thank you. Our next question is from Magda, and she asks, can you talk a little bit about how the agreement of definitions and terms is different in MBSE versus systems engineering and how it fits in your model?
That's an interesting question. So we would say that the difference between sort of straight system engineering and model-based system engineering is that you have that outside representation of your model, and you can have a more detailed, richer, shared understanding of definitions and terms, for example, than you can in a static document. So you can, for example, not only have an acronym or a defined term, but then have that referencing to the document that came from, and that document can link to the guidance for another aspect of your system as well. There's sort of the richness that can be obtained from having the multiple relations, I would say is the major difference, rather than that sort of static document or representation of if you're using standard old style document-based system engineering.
Great, thank you. And another question from Kevin, and Kevin asks, at what point does using a model-based approach return on investment?
That it's fairly dependent upon your situation. So there's obviously a cost to using the model-based, model-centric approach that I've been talking about, the cost of the tool itself, and I guess that depends on your current access and the tool you've chosen, the cost of learning how to use the tool and learning the methods involved with the tool, which depends on your experience. And I guess that weighs against the benefits that I've talked about, but those benefits are dependent upon the complexity of the project and the team size. Personally, having lived it for a while, I would use a model-centric, model-based approach for all but the simplest system engineering projects. So as soon as you start to get any degree of complexity, interaction, humans involved, socio-technical systems, I would start to use that model-based, model-centric approach, and I think that it would provide good benefits for the cost that you would have to outlay to do that.
Thank you, Dr. Harvey. That wraps up our Q&A for today. If you asked a question and we weren't able to answer it during our Q&A portion, we will contact you directly after the webinar to ensure that we do answer your question. If you have any other questions or comments that you didn't send in today, I invite you to post these on the forum at our community site. You'll find that at community.vitechcorp.com. A recording of today's webinar will be posted to our website, and that's vitechcorp.com, and that'll happen by the close of business tomorrow. We would also like to personally invite you to join us on Thursday, May 22nd at 3 p.m. Eastern for a webinar titled 9 Laws of Systems Engineering, and that'll be presented by Zane Scott. You can find out more information about that webinar on our website. In closing, I'd like to thank our presenter today. I'd especially like to thank all of you for your questions today. As we bring this webinar to a close, a survey will open on your screen, either in a new browser tab or in a new window. Please take a moment to provide us with feedback on today's presentation and what topics you'd like to see covered in future webinars. Thank you for joining us, and have a great day.